Welcome to TechWeb Dots. Today, I am going to discuss cloud native design principles based on 12-factor application development, and I will try to explain with very easy explanation. So these are the 12-factor application development principles that you can see here starting from 1 to 12. I will discuss all these principles one by one. Okay, so let's start. But before that, let's understand the background, right? From where these cloud native 12 factor application development principle came and what benefit we are trying to get if we follow all these, right? So 12 factor app is a methodology defined by developers at Heroku for building cloud native applications, and all these 12 factor application development principles also mentioned on 12factor.net. In the modern era, the software is commonly delivered as a service called web apps or software as a service. So that uses declarative format for setup automation to minimize time and cost for new developers joining the project and have a clean contract with the underlying operating system, offering maximum portability between execution environments. And these are also suitable for deployment on modern cloud platforms and obviating the need for server and system administration. It means we need less administration over there and minimize the divergence between deployment and production, enabling continuous deployment for maximum agility. And the last one is we can easily scale, right, without making significant changes in the tooling and deployment practices. Okay, so 12 factor methodology can be applied to an application written in any programming language and which use any combination of backing services, for example database, queues, memory cache, http, or any other type of services. Okay, the last one, it is also applicable for any developer building applications which runs as a service, and all these 12 principles also applicable for microservices as well. And it is also applicable for ops engineers who deploys or manages such applications on the environments. So this is little constructive background what we are trying to achieve if we follow the cloud native 12 factor app development principles. Okay, then let's discuss one by one, right? Why these are important. So number one in the list is the code base, and whatever line you will see in front of the first principle, the code base, it is the golden rule for this written by the Heroku developers that says one code base tracked in revision control and many deploys. So what do we mean by this? We can see one figure as well that depicts this. On the left hand side we have a code base. On the right hand side we can see different environment examples, let's say production, staging, dev 1 and developer 2, maybe the local environment. Let's understand. Cloud native applications must always consist of a single code base that is tracked in a version control system, so we can easily manage. A code base is a source code repository or a set of repositories that share a common root and is used to produce any number of immutable releases. There should be a one-to-one relationship between an application and a code base. It means there should be only one code base for one application, but a one-to-many relationship between the code base and deployment of an application. It means on the left hand side we have a code base, on the right hand side we have the deployment environments. And again, if there are multiple code bases, it is not an app then, right? It's a distributed system, and each component in a distributed system is an application, and each can individually comply with 12 factor principles, right, that we are discussing them number one. So multiple apps can share the same code, that is a violation of 12 factor, right? The solution here is to factor shared code into a library which can be included through the dependency manager. We can include them as a packages, right? Okay, now let's move to the number two, which is the dependencies. As you can see in the figure, right, on the left hand side we have our application source code, and what I'm trying to showcase here is that we are mentioning the dependencies in the file that refers to what packages, what version, and what scope we are using inside the application source code. So that's called our dependencies. And what is the golden statement for this dependencies principle? Explicitly declare and isolate dependencies. Okay, so let's understand this carefully. So most programming languages offers a packaging system for distributing support libraries such as CPAN for Perl, Ruby Gems for Ruby, Nugget for .NET, right? Libraries installed through a packaging system can be installed system-wide, known as side packages, or scoped into the directory containing the app, known as vendoring or bundling. For example, if you are using a .NET framework and you want to install any of the package, any of the library, so you can easily install through Nugget by managing the Nugget package manager. Okay, instead of packaging third-party libraries inside your service, specify your dependency in your Marvin pom.xml. We are taking example of Marvin, or if you are using Gradle, then it will be in settings.gradle, or if you are using .NET, it will be nugget package.config file, where you can see all the dependencies of your application marked as a packages. This enables you to freely move up to newer version very easily. Okay, so a 12 factor app never relies on implicit existing of system wide packages. Okay, so this principle always saying you should mark your dependencies as a package, don't include them directly inside your service or microservice. It declares all the dependencies completely and exactly via a dependency declaration manifest, right? Example we can see in the picture. The full and explicit dependency specification is applied uniformly to both production and dev environment, so there is no discrepancy in different environment, and every environment using the same set of packages, so that it is easily testable and we can rely on them. Okay, now move to the third one. The third is configuration. So this principle says store configuration in the environment. Okay, now what we are actually talking about, you can see in this picture we have an application and it is using the environment, right, or our configuration. Normally if you see in the configuration we put some authentication keys, right? We can see matrix authentication false here. We can specify some URLs that you wanted to use, some port that we wanted to use, right? But let's understand in detail. Configuration refers to any value that can vary across deployments. For example, developer workstation, or it's a QA environment, or it's a production environment. So this could include URL and other information about backing services such as web service or SMTP service, or let's say MySQL service, right? Information necessary to locate and connect to a databases, right? I already given the example of database. Credentials to third-party services such as Amazon AWS, or API like Google Maps, Twitter, and Facebook, right? Information that might normally be bundled in properties files or configuration XML or YML, right? Yet another markup language. So we can mention all these things in our configuration files. So configuration and credentials are separated from the application code, right? This should happen. Credentials are highly sensitive piece of information and should never be shipped with an app code, as it runs the risk of exposing your application's backing services, internal URLs, the resources and the services your application relies on. So these should not be part of your application code. By externalizing your configuration, this helps to simplify application deployment to multiple environments and reduces the risk of leaking the credential and password, and enable more effective release management, right? The 12-factor app store configuration in the environment variables. Okay, only the configuration, often shortened to environment variable, or we can also call them environment, right? But if we talk about highly secret credentials or the information, those should be stored in the secret manager, and that we can use as a service, right? And you can also call them backing service. And that is our next fourth principle, the backing services. So what are these? We are already seeing one picture here, right? That is already depicting so much, right? So what it is showing, let's say we have a production deployment. On the left hand side we have MySQL backing service, outbound SMTP service for sending emails, Amazon S3 service for file storage, right, that we can access for authentication. There's a Twitter API that we can also connect. So all these four are the attached resources, or we can also call them backing services, right? And the golden statement for this service is treat backing services as the attached resources, right? It means those are not directly inside the microservice or your software as a service. A backing service is any service the app consumes over the network as part of its normal operation, right? Example includes data store such as MySQL or CouchDB, messaging or queuing system such as RabbitMQ, or SMTP services for outbound email such as Postfix, and caching systems such as Memcached. The code for a 12-factor app makes no distinction between local and third-party services. What do we mean by this? So to the app, both the attached resources attached via a URL or the other locate credential stored in the web config, right? But a deploy of the 12-factor app should be able to swap out a local MySQL database with one managed by a third party such as Amazon without any changes to the app code. Okay, it means we are not making any change in the code, but we are making only change in the URL. For example, previously we provided the local URL for connectivity of the DB, and if you wanted to change to the Amazon SQL, then we can, or Amazon RDS, we can easily change it via the URL. So there is no need to make any changes in the code. Okay, let's move next. The next one is build, release, and run. This is the fifth principle in the 12-factor app. So what it says is strictly separate build and run these stages, right? So we are especially talking about building, releasing, and running, right? You can see in this picture there is a design phase, there is a build phase, and there is a release phase, and there is a run phase, right? We all must aware about this, right? But let me give you a bit more information about it. A code base is transformed into a non-development, we are talking about, deployed through three stages. And what are these? Number one, the build stage is transform, which converts a code repo into an executable bundle known as build, using a version of the code at a commit specified by the deployment process. And the build stage fetches vendor dependencies, let's say packages, and compile binaries and assets and bundle into a build artifact, for example a war file or a jar file. The output of a build is a package server containing all the environment agnostic configuration required to run the application. This is our build step, right? In the release step, the release stage takes the build produced by the build stage and combines it with the deploy's current configuration, both environmental and the app specific. The resulting release contains both the build and the config and is ready for the immediate execution in the execution environment. By labeling these releases with unique ID, it enables greater capacity for rolling back to previous version from the if anything goes wrong from the historical auditing. So we can also achieve the same thing if you are using ADO pipelines, or if you are deploying, and if your container deployment, containerized based microservices. So the last stage is run stage, right? I think these run stages, if you are a little aware about the YAML, so we also create all these stages in the YAML configuration as well when we are making automation of this whole CI/CD process, in the pipeline process actually. Okay, the run stage, also known as runtime, runs the app in the execution environment by launching some set of the application process against a selected release. It means the run stage, which occurs on the cloud provider, usually use tooling like container and processes to launch the application. Once the operation is running, the cloud runtime is responsible for its maintenance, health, and dynamic scaling. So all these parts are the part of the pipeline. So 12-factor application uses strict separation between the build, release, and the run stage. Okay, let's go to the next one, which is processes, which is again a very important. And what is the golden statement about it? Execute the application as one or more stateless processes. Okay, then what do we mean by this? So 12-factor processes are stateless and share nothing. It means any data that needs to persist must be stored in a stateful backing service, typically a database, because where we can persist a state, right? The processes factor enforce the notion that application should execute as a single stateless process. It means we are not storing any state within the application. In other words, all long lasting stages should be external to the application provided by backing services. An state should not be maintained within your application or within your microservice. This is a useful factor as it means that if one instance of your application goes down, you don't lose the current state. It also simplifies workload balancing as your application doesn't have any affinity to any particular instance of a service. Affinity means we are serving one request and there is some dedicated data that we have to give to the same request again and again. So that is not in your application, but it is stored on your service side. So that is called our session affinity. Okay, let's move to the next one, which is number 7, which is port binding, which is again very important. If you will see in this application, you will note here we have a multiple services and each service has its own address and the associated port, which is open to connect, right? But let's understand by the definition what this principle says. So this says export services via port binding. Okay, so in detail, web applications are sometimes executed inside a web server container. For example, PHP applications might run as a module inside Apache HTTPD server, or Java application might run inside Tomcat, Apache Tomcat server. The 12-factor app is completely self-contained and does not rely on runtime injection of a web server into the execution environment to create a web-facing service. Okay, it means everything will be completely self-contained. We don't need to rely on the runtime injection. The web app exports HTTP as a service by binding to a port and listening to requests coming in on that port. So port binding is really important because we are exporting that one. In local environment, the developer visits a service URL, let's say the local host colon and its port address, to access the service export by their application. But in deployment, a routing layer handles routing requests from a public facing host name to the port bounded web processes, right? Those are managed by the infra team. You can say, in other words, the port binding factor states that cloud native apps should export services using port binding. In other words, the host and the port used to access the service should be provided by the environment, not baked into the app. It means these kind of changes or mapping should not be in the application itself. So you are not relying on the pre-existing or separately configured services for the endpoint. So your cloud provider should managing the port assignment for you, because it is likely also managing routing, scaling, high availability, means you are deploying your application in multi-AC, and fault tolerance, and all of which requires the cloud provider to manage certain aspects of the network, including routing host name to ports and mapping, right? So this step is again very important, right? Even every principal plays a very important role, right? So every service is exposed via the URL and the port. Okay, the next one is the concurrency one, right? This is again important to understand. There's a picture here, right, which is depicting on the horizontally we have workload diversity. It means a process type, let's say web process, worker process, or the clock process. On the vertically we have a scaling, how many processes we are running. Okay, so what is the golden statement about this concurrency one? Scale out via the process model. Okay, how many processes we want to run, right? We can see if we add the multiple process, so we can scale them as well. But let's understand what the official definition says about it. Any computer program once run is represented by one or more processes. Web apps have taken a variety of process execution forms. Okay, for example, PHP processes runs as a child process of Apache and started on demand as needed by the request volume. Let's take a Java example. Java processes takes the opposite approach, with the JVM providing one massive Uber process that reserve a large block of system resources, CPU and memory on a startup, with concurrency managed internally via the thread. So this is a different way of managing the concurrency. So the concurrency factor stresses the microservice, right? Because all these factors are also applicable to microservice, so we will talk about it side by side. So concurrency factor stresses that microservice should be able to be scaled up and down elastically depending upon their workload. Previously, when many applications were designed as monoliths and were run locally, so this scaling was achieved through vertical scaling. It means we are adding more CPU, more RAM, and other resources virtually or physically. But however, now our applications are more fine-grained and running in the cloud space. A more modern approach. One ideal for the kind of elastic scalability that the cloud support is to scale out or horizontally. Rather than making a single big process even larger, you create multiple processes and distribute the load of your application among those processes. So that's how in the 12 factor application, processes are a first class citizen. For example, HTTP request may be handled by a web process and long running background task handled by a worker process. So the process model truly shines when it comes time to scale out. The sheer nothing horizontally partitionable nature of the 12 factor app processes means that adding more concurrency is a simple and reliable operation because we can easily scale. Okay, now the next one is, as the name suggests, disposability. And we can see here in the picture, we can see multiple kettles and a pet, right? The name is Carl. Okay, we will discuss about it later, but let's notice the golden rule about this disposability. So maximize robustness with fast startup and graceful shutdown. So what do we mean by this? The 12 factor apps processes are disposable, meaning they can be started or stopped at a moment's notice. This facilitates fast elastic scaling, rapid deployment of code or config changes, and robustness of production deploy. Processes should thrive to minimum start time, Ideally, a process takes a few seconds from time the launch command is executed until process is up and ready to receive request. Short startup time provide more agility for release process and scaling up. The process shut down gracefully when they receive a term signal from the process manager. For a web process, graceful shutdown is achieved by ceasing to listen on the service port, thereby refusing any new request and allowing any current request to finish, and then exiting. Implicit in this model is the HTTP requests are short, no more than a few seconds, or in case of long pooling, the client should seamlessly attempt to reconnect when the connection is lost. For a worker process, graceful shutdown is achieved by returning the current job to the work queue. Process should also be robust against sudden death in the case of a failure in the underlying hardware. So this can happen. So the inability to shut down quickly enough can also run the risk of failing to dispose of resources which could corrupt data. Way of looking at this is the cattle versus pet model. So what we are saying here, our application instances should be treated more as cattle, that is no emotional attachment to them, fairly easy to replace, numbered, not the named, right? As you can see, it's 1 to 7 rather than pets, that is there is an emotional attachment, nurses back to the health rather than the replace. We can see the name is cat, the car, the cat, the pet, right? I hope you understand the terminology what I'm trying to explain here with the disposability. Now let's move to the next one, which is dev and prod parity, which is again important. We can see here three systems, which is development, QA and production, and all three are looking almost very similar, and that is what we are talking about here. What's the golden rule here for the dev prod parity? Keep the development, staging, production as similar as possible. And why it is important, let's understand. So historically there have been substantial gaps between development and the production. So these gaps manifest in three areas. The time gap. A developer may work on a code that takes days, weeks, or even months to go into the production. The personal gap. The developer write code, but the operations engineer deploy it. The third one, the tools gap. Developers may be using a stack like Nginx, SQLite, or OS X, while the prod deploys using Apache, MySQL, and Linux, right? So these kinds of gaps can be there. So what 12 factor says? So 12 factor application is designed for a continuous deployment by keeping the gap between the development and the production small. How? Okay, the 12 factor developer resists the urge to use different backing services between development and production. But what will happen? Even when adapters theoretically abstract away and difference in backing services. So what will happen if you use in the traditional ways, the time between deploys it can take weeks, but if you are using 12 factor apps way it may be some hours only. So code author versus code deployer. If we are using traditional way, so there's a different people. But if you are using 12 factor F, then it should be the same people who is also committing the changes and also deploying the on piece of code. Here the dev versus production environment. So in the traditional as it is divergent, means different people are performing this task, but in the 12 factor F as similar as possible, right? I mean they are aware about the concept what they are doing. Now, difference between backing services means that tiny compatibilities crop up, causing code that worked and passed test in the development or staging to fail in production. And these types of errors create friction that this incentivizes continuous deployment, and the cost of this friction and the subsequent dampening of continuous deployment is extremely high when considered in aggregate over the lifetime of an application. So this is how it differs, right, from the traditional application approach and the 12-factor application approach. I hope it is clear. Let's move to the next one. The principle number 11, which is logs, right? And we treat logs as a event stream. In the example, we can see there's a logger. It is logging the information and it is received by the message broker, and that is actually persisting this information into DB, or there are other interested services, those who wanted to receive these log messages at live, right? They don't want to wait for it, they want to consume it directly. Okay, let's understand more detail about it. So logs provide visibility into the behavior of a running application. In server based environment, they are commonly written to a file on disk, a log file, but this is only a output format. So logs are the stream of aggregated time ordered events collected from the output stream of running processes and backing services. A 12-factor app never concerns itself with routing or storage of its output stream. It should not attempt to write to or manage log files. Instead, each running process writes its event stream unbuffered to stdout. During the local environment, the developer will view the stream in the foreground of their terminal to observe the application behavior. We can see if you are using VS Code or if you are using .NET Console. So you can see all these stream live in there, right? But in staging or production deploy, each process stream will be captured by the execution environment, collated together with all other stream from the application and routed to one or more final destination for viewing and long-term archival. So these archival destinations are not visible to or configurable by the application, and instead are completely managed by the execution environment, right? So this is what you need to understand, where it will be managed and how it will be managed. The event stream for an application can be routed to a file or watched via the real-time tail in a terminal, right? So this kind of support now it is provided in every environment, either you are using AWS or Azure or any cloud provider. Most significantly, the stream can be sent to a log indexing and analysis system such as Splunk or general purpose data warehousing system such as Hadoop or Hive. So these systems allow for great power and flexibility for introspecting an app's behavior over time, including what it includes finding specific events in the past, large scale graphic of trend such as request per minute, and active alerting according to user defined heuristic such as alert when the quantity of errors per minute exceed a certain threshold. So these are some alarming situation. Now the last one is admin processes, right? As in the picture you can see, the admin processes, those are applicable on the DB, those are also running from the when application is starting, it is version and managed. So what is the golden rule for this admin processes? Run admin or management task as one-off process, right? Means in one go we are talking about here. So what we are trying to say here is this sector discourages putting one-off admin or management task inside your microservice or any of your application which is act as a software as a service. Now in detail, as part of the application deployment, there are a number of one-off activities that you have to complete. For example, such as data migration and running of one-off script in a particular environment that you wanted to run. A 12-factor principle recommended including administrative cores, or you can say tasks like this one, as part of the software code base that is stored inside the repository. It means in your code repository you can add a file that will be your script file or that you wanted to run in the beginning of the environment when it is gonna run. If you do this, one of the script will then adhere to the process and that is defined for your code base. Make sure the script that are only used once have automatic execution so that you don't have to worry about manual running them before pushing the build, right? So here the automation is again a key. In addition, 12 factor principles recommended making use of the integrated tools of the execution environment in order to execute those scripts on the server used for production. So we should definitely go for tools. Now, developers will often wish to do one of administrative tasks or maintenance tasks for the app, such as running database migrations, example manage.python we are talking, migrate in Django, running a console to run arbitrary code, or running one-time scripts committed into the application repo, for example fix bad records.php. So this is the PHP script. Now we already completed all 12 factor cloud native design principles, right? But at the end, by embracing these 12 factor app principles, an organization can really unlock the full potential of the services, or you can say microservice architecture, and propel their application to the new heights of the performance and scalability. We hope this info has helped you to put these cloud native factors into context and understand how they apply to real life applications and understand what tools available to help you when you are developing your application. And I know we discussed the tools for each of the principle rarely, but if you will go for the actual step when you're going to perform, so you can easily find them and you can see what are the tools already there in your organization that you can use in this 12 factor application cloud native development. Okay, now if you have any question you can drop into the comment box, and your feedback is very important because that's the only inspiration for me to make such videos. So don't forget to subscribe and like this video and share this video where it is more relevant within your organization, within your friends, where they can take the benefit of this video. Until then, bye bye, and I will see you in the next video.